Now we want to find the angle AEB. Now where's that? That's down there, see that? It's in this left triangle here. So what do we know? Well, we know this is 90 degrees. Or do we? I think we can safely say that's 90 degrees. And we know these two sides. So what are we going to do now? We'll just sketch it while I'm thinking. So we know 14 there meters, 12 meters there. That's 90. It's a right angle triangle, and we're looking for the angle AEB. Looking for this angle here. Alright, well, let's call it something first. Let's call it X. So that's the angle X. We're looking for X. What's the size of the angle X? Well, looking out from X, we label our triangle. That's going to be the opposite side there. The length of the adjacent is 12. And the length of the hypotenuse is 14. So it's a right angle triangle. We can use a trig ratio, sine, cos or tan, but we want one that works with the adjacent and the hypotenuse, and it's going to be cosine. Cosine x equals, carrying a harp, adjacent over hypotenuse. So we start down here again. Cosine x equals the length of the adjacent, which is 12, over 14. So x equals cos inverse 12 over 14, which is the same as 6 over 7. And bang that into the calculator. And we go shift, and the cos brings up the cos inverse. Fraction key, 6 on top, 7 below, close bracket. And I got 31, something like this, 31.002. So to 2 decimal places, 31.00 degrees is the size of the angle. So the angle, you could write it like this, angle AEB equals 31.00 degrees, accurate to 2 decimal places.